Hey everybody, it's Miss Perenboom here. We're looking at learning target 6B today, which is on writing and solving proportions. All right, here we go. So first off, a little vocabulary. In the last video, you guys talked about what a ratio was, which is essentially a comparison of two different quantities, and it looks a lot like a fraction. Well, a proportion is an equation that states that two ratios are equivalent. So essentially, it's kind of like saying one fraction is equal to another fraction, which is something that we've already done and that you guys should be familiar with. So for example, I could say that the ratio of 1 to 2 is equivalent to the ratio of 5 to 10. And if we think of it in terms of fractions, 1/2 is equal to 5/10, right? And so these ratios are the same, they're equal. Now we want you guys to be looking for the different relationships that exist between the different numbers within a proportion. So for example, I could say that there's a horizontal relationship between the numerators and the denominators. If I start with a numerator of 1, right here, I can multiply by 5 to get the other numerator. And that same relationship will hold in the denominator. So if I start with 2, I can multiply by 5 to get the other denominator of 10. So it's like I'm scaling up my ratio. Okay, similarly, we can take that same proportion and I could look for a vertical relationship. So within that one ratio, is there a relationship between the numerator and denominator? So for example, I could say 2 divided by 2 is 1, and 10 divided by 2 is 5. So again, there's a horizontal relationship and a vertical relationship. Now, every proportion is going to have relationships. They won't necessarily always be with whole numbers, and so look for the ones that seem to be the most obvious when we're working, okay? Also, all these relationships should be multiplicative, meaning you're either going to be using multiplication or division. There's no adding and no subtracting when we're working with proportions. Okay, so let's pause the video, jot down that vocabulary term, and then go ahead and hit play for some examples. All right, you decide to make lemonade for a party you're having, but the recipe you have only makes enough for 5 people. You've got 20 people coming to your party. So how much lemon juice would you need to make in order for all your guests to have enough lemonade? Okay, so looking at this recipe, we have all the different ingredients that we're going to need, and specifically this problem's asking me just for the amount of lemon juice. So I'm going to focus in on the fact that I need 2 cups of lemon juice for this recipe, but that again is only going to make enough for 5 people. I need to make enough for 20. So when we consider the ratio of what we know, right, comparing lemon juice to the number of servings, I need 2 cups of lemonade to serve 5 people. Okay, but I have 20 people coming. I need 20 servings. And so what I'm looking for is an equivalent ratio that's going to have 20 in the denominator. Now I'm trying to find how much lemon juice I need, so I'm going to put a variable up top because I'm not sure what this number is going to be. So I set up a proportion with one unknown number, and I'm going to use either a vertical or a horizontal relationship to find that missing piece. Now as I'm looking at this, I would say that I know 5 times 4 is equal to 20. And so I should be able to do the same thing to the top. And so since 2 times 4 is 8, that's going to let me know that I need 8 cups of lemon juice to make enough lemonade for 20 people. Okay, so this is sort of a classic example of when you would need a proportion, right? The ratio should stay the same. We're just scaling it up. All right, let's take a look at another one. Last weekend, Will helped his father clean the garage. For every 3 hours of work, he took a 2-hour break. If he worked for 6 hours, not including his breaks, so he actually worked for 6 hours, how many hours did he spend taking breaks? Well, again, let's think about that ratio that we are given. We know that for every 3 hours of work, he takes a 2-hour break, right? That's the ratio we know. We want to maintain that ratio, but we're going to use different numbers. We need an equivalent ratio, hence writing a proportion. So the other piece of information I was given is that he actually works for 6 hours. So looking at my labels, which are really important, by the way, you always want to make sure that you're labeling things to be consistent. So hours of work should go on top. So I'm going to say this is equal to 6 over and then x, because I don't know how long he took a break for. That's what I'm trying to find. Okay, so again, look for either a vertical or a horizontal relationship. I'm thinking horizontal will work really nicely here. I know 3 times 2 is equal to 6. And so 2 times 2 is going to give me 4. So he would take 4 hours of break. All right, another one. Last year, Marjorie cooked an 8-pound turkey for 120 minutes based on her cookbook's recommendation. If she follows the same recommendation, how long could she cook or how long should she cook a 15-pound turkey for? Okay, so again, think about what we know. What's the ratio that we have? We have an 8-pound turkey for 120 minutes, right? So pounds of turkey compared to cooking time, 8 to 120. Okay, so I've got a 15-pound turkey, so that's my numerator. So I need an equivalent ratio where the numerator is 15, and I'm trying to figure out what that bottom number is going to be. Okay, this time I don't really have a great relationship between 8 and 15, but I do know a good relationship between 8 and 120. I know 8 times 15 is 120, so I'm going to do the same thing on the other side. 15 times 15 is going to give me 225 minutes. So Marjorie should cook that 15-pound turkey for 225 minutes. All right, how about this one? The ratio of the number of girls to the number of children in Mrs. Robinson's class is 2 to 5. There are 30 children in Mrs. Robinson's class, so how many are girls? Well, start with that ratio, 2 to 5. That was comparing the number of girls to the total number of children, 2 out of every 5. And so I know that there are 30 children, so that's going to be my bottom number, and I'm trying to figure out that top number, how many of them are girls. Okay, so this time I think I'm going to use a horizontal relationship again. So I'm going to say 5 times 6 is equal to 30, so 2 times 6 is going to be equal to 12. So there are going to be 12 girls in Mrs. Robinson's class. All right, one more example before you guys try some on your own here. At the football game, the Leopards scored 3/5 as many points as the Mustangs. If the Leopards scored 15 points, how many did the Mustangs score? All right, so by saying they scored 3/5 as many points as the Mustangs, that means for every 3 that the Leopards score, the Mustangs would have scored 5. Okay, so we're making a comparison between Leopards and Mustangs, 3 to 5. All right, and again, this is a proportional relationship because we want that ratio to stay the same. We're just going to scale it up a little bit because this doesn't mean that they scored exactly 3 and then the Mustangs scored exactly 5. That's just the ratio between the points. Okay, so Leopards scored 15 points. Leopards are on the top here, so I'm going to put 15 over X because I'm trying to figure out how many points the Mustangs scored. I know that 3 times 5 is 15, so 5 times 5 on the bottom is going to give me 25. So therefore the Mustangs would have scored 25 points. All right, number 6. Cassie used exactly 2 cans of icing to cover 24 cupcakes. How many cupcakes can she ice with 3 cans of icing? All right, I'm going to have you guys pause the video here. On your sheet, you have a spot that you can try to set up a proportion and solve it. And then when you think you have it, hit play to check your answer. All right, so hopefully you were making a comparison between how many cans of icing she had and how many cupcakes she was able to cover. So we know 2 cans of icing will cover 24 cupcakes. And so we know that she really has 3 cans of icing now. So if 2 can cover 24, then 3 can cover how many? I would use a vertical relationship here. I know 2 times 12 is equal to 24, and so 3 times 12 is going to give me 36. So she can cover 36 cupcakes. All right, and last one. This is one that you're going to bring back to school, and we'll check it in class. So at Washington Middle School, they keep track of all the books that students read. For every 9 7th graders in the school, 5 of them claim that Hunger Games is their favorite book. Washington School has 90 7th graders. So how many 7th graders prefer the Hunger Games? Okay, so go ahead and pause, see if you can set up a proportion, solve it, and then bring your answer with you to class. When you're ready, hit play for the last bit. All right, and finally, before you close out the video, please take a minute to write down either something you learned or were reminded of, and then what questions you have. So either something that you're not clear on or something that this sort of prompted you to wonder about, but please try to write down at least one answer for each prompt. All right, and you can go ahead and close out the video as soon as you're done. Thanks for watching.